Hello, this is my multimodal text output, and it's all about showing the qualitative characteristics of images formed by plane mirrors and lenses through ray diagramming. Let's start. So first, what is a mirror? A mirror is a reflective surface that bounces off light, thus producing an image. Two types of images are produced by mirrors. It can be a virtual image, where the image is always upright, or it can be a real image, where the image is always inverted. Now, let's move on to the types of mirrors. The first type of mirror is what we commonly use to check ourselves. It is a plane mirror. It is the simplest form of mirror, which is a flat reflecting surface. Now, these two examples here are the two kinds of a spherical mirror. A spherical mirror is a mirror with a curved reflective surface. The first kind of spherical mirror is a convex mirror. It is also known as a fisheye mirror or diverging mirror. It is a curved mirror in which the reflective surface bulges toward the light source. The second kind of spherical mirror is a concave mirror. It is also known as a converging mirror. It has a reflecting surface that bulges inward, away from the incident light. Now that we know the two kinds of mirrors, let us know what is a ray diagram. A ray diagram is a graphical method of locating the image formed in lens or mirror. Let's search the ray diagram of a plane mirror. So, what we see here is an object facing a plane mirror. Two incident rays strike the mirror and has been reflected, and when we extend the reflected rays behind the mirror, it intersects at one point. We can see that the image we use is upright, which makes it a virtual image, and the size or height of the object is also the same, therefore there is no magnification. Now, for spherical mirrors, there are three principal rays that are needed to construct its ray diagram. You may ask, but why does plane mirror have no principal rays? It's because a plane mirror is just flat, and the spherical mirror has a curve. It does not have a principal focus nor a center of curvature. The first principal ray states that a ray of light parallel to the principal axis is reflected through the principal focus. Second, the ray of light passing through the principal focus is reflected parallel to the principal axis. And third, the ray of light passing through the center of curvature is reflected back along its own path. Using the three principal axes, we are able to make a ray diagram for concave and convex mirrors. This is a ray diagram of a simple concave mirror. So, using the three rules of principal axis, you can see here. The first one, a ray of light parallel to the principal axis is reflected through the principal focus. Another ray of light passing through the principal focus is reflected parallel to the principal axis. And lastly, a ray of light passing through the center of curvature is reflected back along its own path. When the intersecting point is below the principal axis, it is inverted. Therefore, the type of image is real. How about for convex mirrors? The orientation for convex mirrors is always upright, and therefore its type of image is always virtual. We can see that there is no intersecting point in convex mirrors. Why? It is mentioned a while ago that convex mirrors are diverging mirrors. It causes reflected light rays to spread out, making the size of the image smaller, but it's giving us a wider field of view. If you want to learn more about knowing the different qualitative characteristics of concave and convex mirrors, with videos included, please scan this QR code. Thank you for listening.